All right, let's talk about that fourth example in arc length. You had stated that you understand arc length because you studied it when you were working with functions of x. Now with parametric equations, it's even easier. If we did have just an equation of x, maybe f of x is equal to 0.4 times the quantity x minus 2 times the quantity x plus 1 times x, and we wanted to know the length of the curve on the interval x sub 1, x sub 2, we would take um, more or less the integral x sub 1 to x sub 2 of the square root of 1 plus f prime of x quantity squared dx. Well, let's think about this parametrically. What if the length of the segment, that red segment, is an under approximation. It's approximation, though, of the length of the curve. In fact, if I were to use the distance formula, that distance is an approximation of the length of the curve. Well, what if I did that and then found some midpoints and broke my segment pieces up like that? That's a better approximation for the length of the curve. And then if I kick it up another notch, that's a better approximation. And if I were to go and do that to infinity, which I'm not implying that 14 is equal to infinity, but it gives us a pretty darn good estimate of what's going on, that's going to give us a darn good estimate of what's happening for finding the length of the curve. So, what we're doing in the calculus world is taking the integral, adding up infinitely many of those t segments, t sub 1 to t sub 2 of the square root of the change in x. Isn't x sub 2 minus x sub 1 the change in x? dx dt, quantity squared, plus dy dt, quantity squared, dt. So, if you look on your note sheet, you'll see the length of arc for parametric graph is as shown. Note that the formula works when the curve does not intersect itself or on the interval a is less than or equal to t is less than or equal to b, and the curve must be smooth. So here's an example 4. Set up an integral expression for the arc length of the curve given by the parametric equations x equals e to the 5t plus 2, y equals 3 sine t squared, t runs from 0 to 4. Do not evaluate. Well, you need to graph it. You need to look at what's happening. But after you do that, we'll just take dx dt is 5e to the 5t plus 2. dy dt is 3 cosine t squared times 2t. So the arc length would be equal to the integral from t sub 1 to t sub 2, but in this case, our t sub 1 is 0, and our t sub 2 is 4, of the square root of 5e to the 5t plus 2 quantity squared plus 6t cosine t squared to the second dt. That's all the news that's fit to print. Thank you for shopping. Come back soon.